So I'm going to tell you what a browser component is, how you can create one, how you can extract existing features into a browser component. Before we talk about that, I'm going to step back and just take a look at the history of our delicious layer cake. So at some point, we had a truly delicious layer cake that looked like this. This is for illustration, so I'm skipping a number of things like IPC and UI and stuff like that. So the important thing there was, this is about 2.5 years ago, is when we had this kind of picture. Now, a problem that people recognized there was that our magical architecture to enable a multi-process sandboxed browser was in that Chrome box, and in that same box we had all of our browser features, bookmarks, history, so forth. And so that was recognized as a problem because it was just too easy when you're creating a feature to add inappropriate knowledge of that feature to some of our core architectural bits. And so John Abdelmalek was the person to start and drive the content module refactoring, which was a pretty big project. I was one of the people involved as well. And so what we did in that project was we put in place this new layer called content. I'm sure by now everybody's more or less familiar with it. So in that box, we have all of the core architecture of Chrome, everything that makes it multi-processed, sandboxed, and so forth. So anybody can take that layer, embed it in their own, create a very basic browser with no browser features, just HTML5. And it has a well-defined API, so the Chrome layer can't really reach into the content layer much. It doesn't know everything about its implementation, so it's also easier for us to change the implementation a little bit without having to change Chrome. So this was a lot better, much better in fact. But now we have this problem, which is, okay, so we had desktop Chrome. Great, desktop Chrome is pretty homogeneous. And then we had Chrome OS. Okay, Chrome OS is very close to Chrome. It's just a few if-defs here and there, to make the code behave correctly for Chrome OS. And then along comes Chrome for Android. Okay, it's still sort of like desktop Chrome. There are quite a few if-defs in the code to make Chrome for Android work. And then along came this project called Android WebView, which is about creating a new version of the Android WebView based on the Chrome codebase. And this was another project which is going like, okay, we want to reuse things from Chrome, but we're very different. It's not anywhere close to being like desktop Chrome, right? So at that point, we said, okay, let's not do that. Let's do something better. And that's when we started to introduce this new layer called components. It's a layer for features that are browser features, essentially, that anybody embedding content might want to add on top of content. So they're actual browser features. They could be like things like bookmarks or autofill. But the important thing is they don't know about their embedder. So any feature that's in the components layer doesn't actually know about Chrome. So it doesn't have to be Chrome that's up there. It can be Chrome or Android WebView or whatever new top-level application we might come up with later. And there are some signs that point to us having more. All right, so before I dive into the details of what a browser component is, I'll just give you a concrete example. So one of the features that Android WebView needed was autofill. And before we started working on componentizing autofill, it was basically in the Chrome directory, and it depended on all these different things. It had concrete dependencies on profile, translate, password manager, many things, sync, and so forth. It also had a concrete dependency on a part of the web data mechanism, which is basically our storage mechanism for different types of data. It had a concrete dependency on the autofill part of that mechanism. So after componentizing this, we moved both autofill and the autofill part of web data into the components layer. We broke all dependencies on all those different things we had dependencies on in Chrome before. And we just put what we needed into a delegate interface that then is implemented by a delegate on the Chrome side and can be implemented by a delegate on the Android WebView side. So, so this makes the dependency graph a lot nicer. There is still something in Chrome that depends on all those different things, but it's a very small piece of code. It's what you might call glue code or configuration code. So that's what it looked like after. And just more concretely, what actually moved, we had autofill directories under browser and renderer, and those moved to components autofill browser, components autofill renderer. And then the generic parts of web data, we extract it into a separate component called web data, components web data. And the autofill specific parts of web data, we extract it into just a subdirectory of autofill itself, so components autofill web data. So that's just a concrete example for you to keep in mind as I go through these more details about what is a browser component. So a component lives in source/components. It's a separate dynamic library in the developer build. It's usually a feature that is like an add-on, like a browser feature that somebody who embeds content might want to add. It usually does not have UI, although there is nothing to prevent you from actually creating a component with reusable UI. That's just not what we have right now. It only depends downward in that layer cake, so it depends on content, base, net, and so on. It can also depend on other components, but in a strictly tree-shaped graph, so no cycles. In fact, if you have a component depending on another component, the component above is considered the embedder of the other component in some cases. All right, it defines a delegate interface to get at whatever services or resources it needs from its embedder. And in terms of lifecycle management, it's the embedder's responsibility to create and configure the component and to own the component, decide when it's going to go away. What about the internal structure? So a component that's named XYZ would live in source/component/XYZ. Its code would go into a namespace XYZ. It should have a strict dependency deps file, so that prevents it from depending up to Chrome or something like that. And it should have an owner's file for the people who are responsible for that component. If it's only used from one process type, which is usually browser, the code for the component can just go directly there into the directory of the component. If it's used by multiple different process types, you would have one subdirectory per process type. So XYZ/browser, XYZ/renderer, and as is typical under /Chrome, you could have a common directory for things that are reused between. Now, if you're creating a new browser component, that's very, very straightforward. You just follow the rules on this slide and the slide before, right? And I really urge you, if you're creating a new feature, think about creating it as a browser component. It's really not any more difficult than writing it straight inside of source/Chrome. And it'll save you from dependency creep in the future. And if we have a new top-level application that needs to reuse your feature, you won't have any new work to do. So consider doing that if you're creating a new feature. So the more difficult thing is taking an existing feature in Chrome and extracting it out of there and down to the components layer. So we've developed a sort of cookbook, step-by-step instructions, and a set of approaches that you can use, and I'll just briefly talk about that. So exfiltration, step-by-step, and exfiltration means rescuing someone from dangerous territory. You first identify a feature you need to extract. Think back to the autofill example. Then you have to work from leaf nodes. In the autofill example, the leaf node was the autofill specific part of web data, right? So we start by doing that one. Then we do autofill itself, because those are two different components. For each component, you write a strict deps file as if it were already a component. So you basically write a deps file that tells it not to depend on the rest of Chrome. And then you actually make that true. And I'll go into more detail in this step and the next one in the next couple of slides. Then you reduce the dependencies you have on the rest of Chrome down to 0. You move your code after that. And you fix up your GIP files. You add any export declarations that are needed so that it can build as a dynamic library in the developer build. And that's all there is to it. Simple. Okay, so what do I mean a strict deps file with temporary exclusions? So here's an extract of a deps file that I'm working with. I'm componentizing sign-in right now. And so you see the first 3 green lines. I'm basically telling the check deps mechanism, this directory is not allowed to depend on the rest of Chrome. It's only allowed to depend on stuff within the same directory. Right? That's like the first step that I do. And then at the bottom, we have a section called specific include rules. And I've actually identified a few files that will stay in Chrome. They won't be moving with the component. And so for those files, I'm saying plus Chrome/browser plus Chrome/common. They're allowed to depend on the rest of Chrome. They're going to stay. What about the rest? So if I didn't have that section in the middle, the get this list to 0 to do there, and I ran the check deps tool, it would fail. It would complain about 100 violations of dependencies that I've told it can't have. So what I can do is I can run the checkdefs tool with a flag that generates a list of temporarily allowed rules, and that generates this list of exclamation mark prefixed rules. And an exclamation mark prefixed rule is just like a plus in that it allows the checkdefs tool to pass, but it's a little bit different in that if somebody adds an include of one of these files, then they will get a pre-submit warning when they try to upload or submit their change. So by making it an exclamation mark prefixed rule, you're helping yourself. You're preventing others from working against you when you're trying to componentize. So this is the list I need to get to 0. So how do I get that list to 0? Well, I'm breaking dependencies, and there are a few ways to do that. We have this cookbook now. There's the URL. I'll just touch on a few common approaches. The most common by far is dependency inversion or dependency injection, where instead of concretely depending on something, your component defines a delegate interface or a set of interfaces, and the embedder has to implement those and provide an instance of an implementation. So that's one way for your component not to know about the embedder. A very common thing that also happens in Chrome is that a lot of features in Chrome are initialized by passing them one of these huge objects like profile, which basically has everything, right? And then the feature just turns around and it's just fetching a couple of fundamental objects, a pref service, maybe a task runner for a thread or something like that. So instead of passing it that huge object, just pass it the more fundamental objects. This is just classic computer science kind of stuff. The one other thing I wanted to mention is sometimes you'll have a hard time determining should this particular class move with the component or stay in the embedder. And the reason will be like it feels like a part of the component. It has maybe it has a state machine that's fundamental to the component, but at the same time it's bringing in all these different dependencies. And so when you have that kind of case, often the right thing to do is to actually split that class into two. One is just a core business logic class that will move with the component, and the other is just an integration type of class that'll stay in the embedder. There's more in the full cookbook. There's going to be more details, links to concrete change lists where we applied some of these methods and so forth. So you can take a look at that. Now, there is a small team working on componentization. So far, we've mostly been working on actually componentizing things that were needed by Android WebView so that they wouldn't have to have ifdefs in Chrome. We're still working on sign-on, and extensions is the biggest one we're working on right now. But we switched more to enabling others to componentize more easily. So most of the team now is working on things like extracting the profile keyed service framework. I don't know if Powell is here, he's working on that. That'll make it easier for you to componentize some things because a lot of components need to be profile keyed services. We're switching to typed notifications. Again, Powell. We found that when you're using notification service, which is an untyped kind of notification mechanism, it makes it actually a lot harder to see the dependencies of your thing and to extract them. So we're actually deprecating notification service over time. And we're doing other things to make it easier to hack on Chrome. And in general, we just want to enable you to componentize, to reuse, and just to make it easier to hack. So any ideas you have, send them our way. And I'll just end with a quick call to action. If you're writing a new feature, again, I'd really recommend thinking about making it a browser component. You'll save yourself from dependency creep in the future, especially as others start maintaining it or modifying it. And if a new application needs to use it, you'll have no work to do. And if you need to reuse a feature, don't add ifdefs into Chrome, extract it to a browser component. That's the way we do it now, essentially. All right, there's further documentation on chromium.org. You can search for those keywords or use those short URLs. If you need help, there's the email address for the team, or you can reach out to me personally.